Good morning, sir. Myself Mahesh. I'm from Computer Science Department, and my topic is PN junction diode, and my roll number is 5N4. So, my first slide is PN junction diode. Introduction to the PN junction diode. A PN junction diode is a semiconductor device made up of P-type and N-type materials. This means we know that PN junction is a semiconductor device which is made up of P-type and N-type materials. The property of PN junction diode is it allows the current to flow in only one direction. Due to this property, uh, it makes used in most electronics devices. The structure of PN junction diode is uh, the N-type material is connected to the negative terminal of the battery, and P-type is connected to the positive terminal of the battery. Uh, the PN junction consists of two regions, that is P-type and N-type semiconductor devices. We know that P-type is a mostly the majority charge carriers are holes, and the N-type semiconductors are majority charge carriers are electrons. When you combine these two P-type and N-type materials, due to the deficiency of charge carriers, electric field will be developed at the junction. The formation of p-n junction diode. When p-type and n-type materials are joined, electrons moves from n side to p side. This process creates a depletion layer due to the charge carriers. When you apply the sum of the charges near the junction will try to, due to the proper tendency to move towards the positive particle, that they get neutralized. Due to a deficiency of some charge carriers, a positive charge will be developed across the junction due to the giving the electrons in p-type material. Due to gaining the electrons, a negative charge will be developed across the junction. This creates a electric field across this depletion layer. And one more, the remaining electrons won't diffuse because when they try to get neutralized, these positive charges and these positive charges will repulse each other. So the remaining electrons won't diffuse. To move these charges, we need to provide an external DC voltage. After providing external DC voltage, now we will see some more what is the forward bias conditions. The p-type semiconductor is connected to the positive terminal of the battery, and n side is connected to the negative terminal of the battery. And due to providing an external DC voltage, the charge carriers will move from p-type to n-type material. After moving the p-type to n-type material, the charges present in p-type get neutralized with n-type material, and due to getting neutralized, the number of charge carriers also reduced, and the length of the depletion also gets reduced. As a result, the flowing of electrons produces a current in the circuit. Now we will see the reverse bias condition. In reverse bias, the P side is connected to the negative terminal of the battery, and N side is connected to the positive terminal of the battery. So the positive particles will move to the negative terminal of the battery, and electrons will move to the positive terminal of the battery. So there is no effect of these charge carriers on the depletion layer. So the length of the depletion gets increased. Uh, it increases the barrier, widening the depletion region and preventing current flow. Only some of the current will flow. That is due to the minority charge carriers in the p-type material and minority charge electrons in the n-type. So this will get neutralized and will cause a small amount of current flow, but that won't flow current in the circuit. That is also known as reverse saturation current. We will see in the next slide. And now we will see some of the characteristics of current voltage. Uh, the current voltage characteristics demonstrate the behavior of diode under the different bias condition. In forward bias, uh, the exponential increase in the current with voltage. This is due to we observe that in forward bias the number of charge carriers get decreased. The current will flow more. So for a germanium material, the value is 0.3, and for silicon diode the value is 0.7. After providing the up to 0.3, the for a germanium diode, after providing external DC voltage above 0.3, the current will be maximum. If we use silicon diode, until the 0.7 the current will be maximum. After providing an over above 0.7 the current will be maximum. For a reverse bias, only minority charge will produce some current, so that the current will not produce in the reverse bias conditions. Now we will see what are the applications of PN junction diode. Now, due to having the property of flowing only in one direction, they are widely used in rectifiers to convert AC to DC, and they are also utilized in signal demolitions and voltage regulation circuits. Additionally, they play a crucial role in light emitting diodes and solar cells. What are the advantages of PN junction diodes? They are simple device with straightforward construction and operation. PN junction diodes have a fast switching speeds, making them suitable for high frequency applications. They exhibit high reliability and a long operation life with minimal maintenance. Now we will see what are the limitations of PN junction diode. A PN junction diodes have a forward voltage drop typically around 0.7 per silicon diodes. This is one of the limitations, because up to 0.7 the current will not be maximum. The current is constant. They can only handle limited reverse voltage breakdown occurs. The temperature variations can affect their performance and characteristics. By decreasing or increasing the temperature, the performance and characteristics can be different and may affect the PN junction diode. Finally, conclusion. PN junction diodes are fundamental components in model electronics. They are widely used in model electronics. Their unique properties enable a wide range of applications in circuits and devices. They have a property of flowing current in only in one direction, so they are used in circuits and devices. Understanding their operation is crucial for anyone working in electronic engineering or related fields. For a student who is studying in electronics, it will be very crucial to understand these operations, and so that he can implement it in various fields also. Next, finally, thank you.